Alright, today we are going to be learning about elements, mixtures, and compounds. Now all these things are made up of atoms, which we learned about yesterday and the day before. So, we have elements that are pure substances that cannot be separated into simpler substances. So, that's our periodic table of elements. We looked at a little bit in the Bill Nye video, and those are things that are found in nature. You can't make copper into something, you can't break it down into something other than copper. Okay, the molecules that make up copper are copper molecules. You need to have your notebook for this activity or this video, and the first thing you need to write is the definition of an element. So go ahead and pause it and write this down. Okay? Next we have compounds. Now, compounds are also a pure substance just like elements, but they're made up of two or more different elements joined by a chemical bond. So they have new molecules that are made up of different elements bonded together. We're talking bonded together, so you can't separate it with a knife. Okay? The only way you can separate bonds like this is to chemically separate them. For instance, well, all compounds have a chemical formula. So this is the chemical formula for just regular white sugar. C6H12O6, and that's 6 carbon molecules or 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms, and those all combined, all of that. So that's 24 different atoms combined to make one sugar molecule. You cannot separate a sugar molecule into something, well, you can't separate it into something different by physical forces. Okay, you would have to use some chemical process to separate that back down into carbon, hydrogen, and oxygen. Go ahead and pause it again, because you will need to write down the definition for a compound, which is just this part. The pure substance made of two or more different elements joined by a chemical bond. Okay? A little bit more about compounds, you don't need to have this part written down, is that it's made of elements in a specific ratio that's always the same. Water, most of us know as H2O, which means there's 2 hydrogen atoms and 1 oxygen atom in every single molecule. You won't find little hydrogen pockets mixed in unevenly with water. It's not the way it works. Water will always be H2O. Always have 2 hydrogen atoms to every 1 oxygen atom. That's the way it works for all of them. CO2 is produced by us when we exhale. Plants take it in, and all CO2 will have that same ratio. 1 carbon, 2 oxygen, every time. All the molecules, CO2 will be like this. Sodium chloride, and sodium is tricky because sodium is Na, is just regular table salt. You cannot separate table salt into sodium and chloride except through a chemical process. And every single molecule of salt will have 1 sodium and 1 chloride every time. Okay, that's what it means by the ratio is always the same. The last thing about compounds, as I've been saying, is that they cannot be separated by physical means, only by chemical means. Okay? That means you can't break them apart with a hammer. You can't sift them apart. They are bonded, chemically bonded together. All right. Next one and last one is mixtures. And mixtures are a combination of two or more pure substances, but they're not chemically bonded together. They're held together by physical forces. No chemical change involved. So if you have cinnamon and sugar, that's a mixture. You've mixed cinnamon, you've mixed sugar, but can you separate those things? Yes, you can. It would take forever, but you could separate them back into sugar and cinnamon. There's no change between these two elements going into this. They are still the same things, they're just mixed together. Sorry, pause this. You need to write this definition in your notes, which would be a combination of two or more pure substances that are not chemically bonded. So go ahead and pause me and, sorry, feeling a sneeze coming on. Pause me and write that down, okay? One more thing about mixtures. When you mix something together, each item retains, that means keeps, its properties in the mixture and can be separated physically. So if you make trail mix, the items in your trail mix are not changing. You've made something different by making trail mix, but you can still separate the cereal pieces from the pretzels from the M&Ms. It's the same way with all mixtures. All they are is the elements put together. So if you have something in your water, if you have water that comes out of your faucet that's not necessarily clean, it has some minerals in it that you don't want, you can filter it and get water, but you don't get rid of these pieces. They still have the same properties. Nothing's changed. You've just taken them out of the water. Okay? No change in properties here. Now, this you do not need to write down, but you need to understand what it means. This is a mixture versus a compound. Now, mixtures are heterogeneous, or heterogeneous, as some people say, which means you might have more clumps of things in other places. So when you have trail mix, sometimes you'll have more pretzels than anything else. But your friend could scoop a bag of trail mix from the same bowl and get more marshmallows than anything else. And that's because it's a mixture. It's not going to be perfectly distributed. Each substance keeps its own properties. So everything in your trail mix is still its own thing. It's just mixed together. And it can be separated by a physical process. You can sift it apart. You can take it apart. Example would be seawater. You can get the salt out of the water through many ways, but you could evaporate the water off and it would leave the salt behind because it is a mixture. And some water can be saltier than other water. Also, most rocks are a combination of minerals that can be broken apart. We mine for coal and gold in physical ways, and so you can use the physical processes to separate those. Now, our compounds are homogeneous. Now, that means they are perfectly distributed every time. Water cannot be more watery here. It can't be more hydrogen-y, I don't even know how you'd say that, or oxygen-y here. It will be water all the way through, okay? It has properties that are different than the elements you combined. So hydrogen and oxygen are both gases. But when you combine them, they make water, which is very different than a gas. And that's because it is a compound. Our trail mix keeps all the individual pieces, but when we make a compound, completely different. And you have to get them apart using a chemical process. So you'd have to get in there and find some way to get those atoms to separate or to break their bonds. Examples of that would be water. We saw in the Bill Nye video, you can separate water into hydrogen and oxygen. That's not through a physical process. And salt is another compound because it's not like sodium or chloride. You mix it together and you have something completely different. Please bring those notes to class tomorrow.